So the first thing I'm going to do is rewrite it, right? We don't want roots. Anytime we're doing derivatives or antiderivatives, roots are not what we want. We want powers. And this is 1/2 power. So like we were talking about, the derivative, I focused on two things. I focused on this guy and this guy, because those are the guys that need to cancel out, the x's, right? On the neck, eventually down the road. This is the inside, and if I take the derivative over here, I'm gonna get something x squared, right? And I see x squared is already built in. So this is the guy that I'm gonna choose, okay? So I'm gonna go over here to the side, and that's the guy that I want to make third power, my u. Okay, once you do that step, everything kind of just rolls. Next thing, find the derivative of u, du. What's the derivative of u? Negative 12x squared, and then don't forget about a dx, right? Solve for dx. So I'm going to divide both sides by negative 12x squared. So I get 1 over negative 12x squared du equals dx. Now comes the substitution. Okay? All right, so let me substitute everything back in. X squared first. I didn't do anything with x squared, so x squared has to stay. Next is the negative 4x, 1 minus 4x to the third. That one was my u, right? That guy is my u. So that guy I'm going to substitute with u. It's to the 1/2 power. Right, and then dx, I'm going to substitute that in now. dx is negative 1 over 12x squared times du. Okay. I want the x's to go, I don't want anything other than u's here. And luckily the x's do cancel out, right? X squared divided by x squared makes 1. So I'm left with u to the 1/2 power times negative 1/12 times du. All right, that's what I want. No x's involved, just u's. So remember, we use this guy. This guy doesn't have an x, so it's going to go to the front. So it's going to be negative 1/12 to the front, u to the 1/2 power du. Now I can do my antiderivative. U to the 1/2 power, we're going to use the power rule. So I get negative 1/12 times. If I add a power, it's going to be 3 over 2. And then I'm going to divide by 3 over 2, right? I'm going to divide by 3 over 2, but instead of dividing by a fraction, right, we multiply by the reciprocal, which is 2/3. So when you do that, you're going to get negative 2 over 36, which is negative 1/18. Then you're going to move u back in. So u to begin with was 1 minus 4x to the 3rd power. And you were done. Okay. So like I said, there's nothing, when you're doing U-substitution, there's no other cases. That's pretty much cut and dry. Okay? The only kind of thing that is the trig and the natural log and the e. That's why we did that stuff last week. Okay. But again, you're still looking for the derivative. You're still looking for, I'm going to choose a u where my derivative is built in. It doesn't matter what function it is. Okay? All right, so let's do the one underneath, letter G. So again, I'm going to rewrite it so I don't have roots. So I have x. Then I have, it's negative 1/3 power because it's on the bottom and it's a third root. So that's going to be negative 1/3. And then on the inside, it's 2x squared minus 1 dx. Here's a question. Can I move this x to the front? No, because it's not a coefficient. It's a function. X is a function. It's a variable, right? So yeah, I got to leave it like that. Okay? Next step, pick a u.
2x squared minus 1?
Because it's not only the inside, but its derivative is going to be something, it's going to be 4x, right? Which will cancel out with that other x. So 2x squared minus 1 du is 4x dx. Solve for dx. So I get 1 over 4x times du equals dx. Substitute time. X stays because I haven't done anything with it. Parentheses are now going to become a u because that was my u. Power stays. Dx is not dx anymore. It's 1 over 4x times du. Will the x's go away?
Yeah.
They will. So I get so I get u to the negative 1/3 times 1/4 times du. The 1/4 I can move to the front because that's a coefficient. 1/4 u to the negative 1/3 du. Antiderivative. Now power rule. 1/4 times, if I add a whole power, I'm going to get 2/3 power. And then instead of dividing by 2/3, I'm going to multiply by the reciprocal plus c. Let's see, 1/4 times 3 over 2 is 3 over 8. So I get 3 over 8, put u back in. 2x squared minus 1. And here we go. Okay. All right. Okay, so the next one I want you to try on your own. H, I want you to do that one on your own. That one has a root, but it was already been changed for you. So see what you can come up with. Do that one on your own and we'll talk about it in about 5 minutes or so. Okay, so I haven't finished the problem, and I know you guys are still working, but I wanted to start. I did the first couple steps. First thing was I rewrote it. 8x divided by 3, and then the root. When you write it like that, it becomes a little easier to see what the inside is going to be. Okay. I can't move 8x divided by 3, a common mistake is trying to move this guy to the front and saying, oh, it's a fraction, I can move it to the front. No, it's got an x, so you can't move it. Okay? Sometimes I've seen this, and this is okay. I've seen this, where students do this. 8/3 times x times, and then they move the 8/3 to the front, but they leave the x. That's okay, you can do that, and just leave x, that's okay. But I can't take the 8x divided by 3 or 8x over 3. I can't take the whole thing and move it, okay?
Could you move out 1 over 3?
If you take out 1 over 3, you leave 8x, right? Yeah. That works too. Absolutely, yeah. So instead of that, yeah, 1/3 take out and then leave 8x, that works. That will work, yeah. So yeah, you definitely can be creative with some of these. It's up to you. Okay. The steps might not be exactly the same, but in the end, we'll get the same answer. Okay, so the x's cancel out. So I get 8/3 times u to the 1/3 times, now it's negative 1/6 du. So now I have two fractions that I can move to the front. This guy can move to the front. This guy can move to the front. So that's going to be, you'll have 8 over 3 times negative 1/6. And then you'll have u to the 1/3 du. Okay. And then you're going to have, so you have 8/3 times negative 1/6, sorry. And then you're going to have u to the 4/3 plus c. Instead of dividing by 4/3, I'm going to multiply by 3 over 4. So you can multiply all those fractions. Let's see, you're going to get negative 24. I think all those fractions will be reduced to 1/3. Because you can go, let's see, this guy divides by 3, this guy divides by 3, this guy divides by 4, so does this guy. So you get negative 1/6. No, negative 2/6. Negative 1/3, yeah. So negative 1/3, and then move u back in and you're done. 8 minus 3x squared. All right, let's try another. We did J, we did K. Try now M. M is a special case. M I want to do with you guys. So let's do M, and then if we have time, I'll give you a few extra problems to do. M is a special case. These are rare. Maybe 1 out of every 20 problems that you do using antiderivatives, you'll run into a problem like this, and I'll show you why it's rare. You won't see the rarity until later on. Okay, so first thing, rewrite it. It's not x to the 3rd, it's the 3rd root. It's x to the 1st power. So x plus 1 dx. So you might be able to spot the problem, the issue we're going to have here. Can anyone see the problem we're going to have down the road? We haven't had it yet, but we're going to run into a problem. Does anyone see any issue?
The fact that it's either way, if you get the derivatives of everything,
Close, you're getting there. It has to do with this up here. What are the two things that I can choose to be u? There's two things I can choose to be u.
X or X plus 1?
I can choose x by itself or x plus 1, right? And yeah, what's the rule, right? We want to choose the u that its derivative is built in. Well, the derivative of the green is going to be a 1. That's not x. And the derivative of the yellow is also going to be 1. That's not here. That's where we're going to have an issue. Okay? So what I'm going to do is I'm going to go back to the rule that says the argument. So I'm going to pick the argument, the inside, the green. That'll be my u. Okay? Okay, so we got u here. So u is x plus 1. Divide by 1, divide by 1. You get 1 over 1, 1 du equals dx. Move everything back in. This becomes u, and then I move in dx, so it's a 1 du. Now the problem becomes clear. What is the problem?
Can't take away that.
X's won't go away, right? That x will not go away the way it's shaped out yet. So this is what we do. We get a little creative again. I know that u is x plus 1, right? What I'm going to do over here is I see there's an x here. I'm going to solve this guy for x. I'm going to solve u for x. Because the problem is, if I had all u's left here, it'd be okay. The problem is I have an x. So I'm going to change that x to a, with respect to u. So what is it in terms of u?
X times du?
No, it's right here, watch. It's easier than that.
Just subtract 1.
Solve that for x.
1 u equals X.
So it would be x equals u minus 1, right? Is that clear how I got that? I just subtracted 1 from both sides, and it became u minus 1. Okay. So now what I'm going to do is I'm going to use this guy and do another substitution. Do I see x anywhere? Yeah. So instead of x, it's now going to become u minus 1. The 1 you don't have to write anymore because the 1 doesn't matter. It's always there. Now I'm okay. I have only u's. What do I do next? Well,
Plug in.
not plug in, because I haven't done antiderivative. I'm going to do distributive property. I'm going to distribute the monomial to the binomial. You guys have done this millions of times in your career, in your life. Okay. So we have u to the first power times u to the 1/3. What do I do with the fractions there? Multiply or add them? Add them. So when I add them, I'm going to get u to the 4/3. Yes, 4/3 power. Minus u to the 1/3. And then du is still there. Now I can use the power rule. I just have u in 2 spots. It's okay. So I'm going to add a power. So 4/3 plus 1 whole is going to be 7/3. Divide by 7/3, which is the same thing as dividing or multiplying by 3/7, minus Add a power, you get 4/3. Divide by that new power. So really you're just multiplying by 3/4 plus C. Plus C. Move U back in, X plus 1. I just have to move it into 2 spots instead of 1 because there were multiple U's. And you're done. That'll happen, like I said, like 1 every 20 problems, you'll have something like that. It doesn't happen a lot. I think on your practice 6, I think there's 1 question on there that you have to do this. You'll know it because this won't happen. You won't have a derivative built in. You'll be like, which one is U? If I take, it's the same function, right? They're the same. One of them, you're always looking to be a bigger power than the other, right? And that's the one you start with.
It's number 10.
What?
I think it's number 10.
Yeah, on there. Let's see.
For the answer for this one, do we not add the power back down to the?
Oh, I forgot. Yeah, no, totally. Yeah, that's just a typo on my part. Yeah, so it should be 7/3. Yeah, thank you. Yes, it would be number 10. Yeah, you're right. Number 10 on your practice is that situation. Okay. All right, so we got about 20-ish minutes, so I'm going to give you a few. So there should be, you guys should have some space on your notes, right? I think the back is blank. Yeah, the back is blank. I'm going to give you a few problems to do just for extra practice because, like I said, the hardest part about this is just practice, right? It's just practicing. So we'll call this extra practice. Extra practice number 1. Okay, let's try this one. I'll give you, so cosine. Okay. Try those two. So what's the derivative of cosine?
Sine.
Do you see sine anywhere here?
No.
So that means I'm not going to choose cosine as my u. Okay? I have this guy here, and its derivative is going to be, yeah, it'll be a constant. They won't have a, so that's why I'm going to choose this guy as my u and not cosine, not the whole thing. Some people choose the whole thing, right? That would work if there was a sine in there, but there's no sine anywhere. So I got to just choose the angle part. So you got 2 plus, it really is 1/2 x. That's another way to write it. X over 2 is just 1/2 x. So if you take the derivative, you're going to get 1/2 dx, right? Then if you divide by 2, right? You're going to get 1/2 divided by 2. So if you have 1/2 and you split it into 2 groups, how many are in each group now? If you take a half of something, 1/4, right? If I have half a pizza and I give half over here and half over here, now they have 1/4. So it would be 1/4 du. Okay. Put everything back in, cosine stays. This becomes u, and now it becomes times 1/4 du.
How come we didn't do keep change split?
I did keep change split. 1/2 divided by 2.
Did you divide the 1/2 by 1/2?
Yeah, so like if you have half of something, all right, so if you have half right here, and I want to take that half and give it to 2 different groups, how many is each group going to get? 1/4. Or another way is 1/2 divided by 2, 1/2 multiplied by reciprocal, 1/4. Either way it works.
Aren't you dividing it by 1/2?
No, divided by 2.
Why are we
Oh, sorry. Yeah, you're right. What am I doing here?
that was between
Yep. Let's see. So 1/2, it would be divided by 1/2, right? So what am I dividing by 1/2? What's going to be on top?
2,
Not 2.
5,
What's always there? 1.
1.
So 1, if I have a whole and I divide it by half, it's not 1/2 because that's divided by 2. So if I have a whole, and you're dividing it by 1/2, so you're not dividing it by 2, you're actually doubling it, yeah. So it's 1 divided by 1/2, 1 times 2/1, which is 2. If you divide some, it's kind of like a double negative. If you divide something by a half, it's going to double. If you divide something by 2, it's going to be halved, yeah. So it's going to be 2. So change 1/4 to 2. I can move that 2
Derivative of cosine is just sine.
So the derivative, yeah, so we're looking for the antiderivative. What's the antiderivative?
Oh, sine.
It would be sine, right, yeah. So 2 times sine of u plus c. U was 2 plus x over 2. That one was different than the one we did here because that one had a sine and a cosine in there. So then I could use one of those as my u. But the guy we just did not. That guy only had a cosine. So that's why I had to choose the parentheses as my root. Okay. All right, last one, number 2. So number 2 is 2 over x plus 2. And then I got a binomial x plus 2. Now you can change it. You can move it up to the front. You can rewrite it like this. 2 times x plus 2 to the negative 1. And then move the 2 to the front because the 2 is just a 2. Right? And then choose this one as your u. There's only one thing to choose as your u now. So it'd be 1 du. Divide both sides by 1.
Would that be dx?
Dx, sorry, yeah. Dx equals 1 du. Now, what happens if I take the antiderivative of u to the negative 1? going to be u to the 0 divided by 0, right? Which we can't do. So what is the antiderivative of going to be then? What happens then? What do we use?
Natural log?
Becomes a natural log. So it's natural log of u plus c. Now sometimes, and they put u back in, sometimes you'll see these guys around that. Is it required? It just depends. The reason they put bars around the natural log sometimes is you can't have a negative natural log. Doesn't exist. Negative natural logs, period, don't exist. So any number you plug in there has to be positive. That's why. That's why sometimes you'll see that. If you don't put them on there, I won't mark you wrong, but sometimes multiple choice, they'll have like parentheses in one, bars in the other. Always choose the bars when you're dealing with natural logs.